So I'm going to do two more things with structure. I'm going to first show you how to apply a more complicated load to your model. So I'm going to do something like a wind load to this tower. And then I'm going to show you how real-time this analysis is. So I'm going to create a situation where I start to subtract some of these members, and I can get real-time feedback about how the forces are behaving in my tower. Okay, so when we first did this, we created a very simple gravity load, and this will basically apply set gravity force to each node in our model. But we might want to do something more complicated, like we might want to apply a specific load to each point, but only on one side of the model to simulate something like a wind force. This is one example, of course. You can also imagine doing something like taking all the floor plates and using only these nodes and applying a pressure to those to simulate something like a live load. And to do this, we basically have to find all the points that we're interested in, and once we have those points, we can apply a load to those points. Okay, so before we feed those into Grasshopper or to Karamba, we have to define those in Grasshopper. And for that, I'm going to use a little trick. I'm going to start with all the points in my model again. So those are coming out of this point node. And I'm going to start with those points, and I'm going to basically create a line from all those points going in the direction of my wind. So I'm going to have a line going in the y direction. And then I'm going to intersect all those lines with the original surface. And that's going to tell me if the point is on the front or the back of the surface, okay? Because if it only intersects once, it means that it's on the front. If it goes from here and goes through the geometry, it'll have two intersection points. And that's going to tell me that it's on the back of the surface, and I'm not going to use those in my load application. Okay? So first I'll create my lines, and I'm going to use the line SDL component. I'm going to feed all the points into the start. So we've seen this component before. Just to make this easier, I'm going to get rid of all my transformations so you can see the original geometry. So this will create a line going vertically for one unit from each starting point. For the direction, we're just going to change this to the unit y vector. So now all these lines are moving in the y direction. And for the length, we're just going to assign some arbitrary, fairly large length. So now we have all of these lines. Okay, so what I'm going to do is I'm going to calculate the intersections between each line and the original surface. The original surface I have back here in this loft. I'm basically going to create a geometry node to capture those lofts. So this defines my exterior surface of my tower. I'm going to drag that down here. The first thing I need to do is join all those surfaces into one B-rep. So I'm going to pass those surfaces into here. I have to flatten them first. So from here I get one B-rep, and this, if we hide everything again, this is my original tower surface. Okay, and now I'm going to use an intersection. So I intersect the B-rep with all the curves. So I'm going to use this physical B-rep curve intersect. For the B-rep, I pass in my tower surface and then all the lines here. It's going to calculate all those intersections, and it's going to give me all the intersection points for each line. So I passed in here 450 lines, and I get 450 branches as a result. You see the first part here, it's going to go from 0 to 449. Those represent all the lines, and then there's always either 1 or 2 points in each branch. So there's one point if the point is here and the line just intersects at the starting point, but if that point is back here, the line will intersect that surface twice. Okay? So to figure out which points are on which side of the surface, I can just basically figure out which intersection lines contain 1 point and which contain 2 points. So I'm going to create a list length node here. So this will tell me how many intersection points are within each branch. If I do a panel node here, you can see that what happened is I still have a branch for each line, but now it tells me if I have 1 or 2 intersections. Now I'm going to do a logic node, say smaller than 2. Pass that into here. This is going to give me a true. If there's only 1 point, and a false if there's 2 points, right? And now I'll use the cull pattern node again to basically only pass those points which resulted in only 1 intersection. So I'm bringing all the points into here. There's 450 points. I'm going to pass all of these results into here. There's 450 true-false statements. I'm just going to flatten those into one list because I have one list here and pass those into the pattern. So now what I have is just the points on the front of my surface. And that's only, this is set up so you can pass any vector. Here I have the y vector. I can also use a unit z vector as my direction. It'll give me only the points that are visible from the z direction. But you can use any direction. So if you're doing wind load, you can feed in the primary wind direction into here. Okay, so once I have these points, I can start to apply a force to each of those to create the loading for my structural model. Right, so to apply a load, I am going to use one of the load components. There's a variety of ways to create loads in Karamba. The simplest one is a gravity load. The next simplest one is just to apply a certain force to every point. And once we have the points that we want to apply the force to, we can create loads out of those points. So here I'm going to go down to the load menu and go to point load. So point load will take a vector. The vector defines the actual force that I'm applying to each point. It'll take in a series of point indices or points I can implement here. And then again, I can specify a load case to differentiate it from other loads in my model. So I already have one load. This is defined as load 0. And I can specify this as a separate load into my model. Okay, so the first thing I'll do is I'll pass all my points into here. And then I'll create a vector to represent the load. And I want to just use my unit y vector again. I just want to apply a load in the y direction. Okay. And then into here, I can pass the strength. This is the factor. It'll specify the magnitude of that vector. And I want to apply a large negative value. So I'm going to set that to negative 100 again. So now this is defining my the vector of my force. So this is negative 100 kilonewtons in the y direction. And for my load case to differentiate it from my gravity load, I'm going to give it the load case of 1. And then I'm going to drag this load into the load input, but I'm going to hold shift. Because like all other nodes in Grasshopper, this will accept multiple inputs, but you have to hold shift. I'll pass all those in. And the last thing I'm going to do is I'm going to flatten all those loads so they all come in at the same level. So now I just have a variety of loads. I have one gravity load and I have a bunch of point loads. But because I have them set on different load cases, I can actually differentiate between them in the analysis. Okay, so now that load is being calculated in my analysis. If I turn my, I'll turn my points off, and I'll turn my beam view on, and I'll give this more deformation. You can see that now the model is deforming much more, and it's not just going straight down, it's actually following the wind load as well. And by default, this model view, to show the deformation, will show all your load cases together, but you can actually specify which ones. So if I want to just look at gravity, I can look at 0. If I want to look at just the wind load, I can look at load case 1 here. and all the visualization, all the numbers will change to correspond to your new loads. You can see in this case we have a lot more red. There's a lot more tension loads in the building because now it's responding to this lateral wind force instead of just gravity. All right, so that's a basic setup of different loads and supports, and you should be able to use some aspect of this for any problem you have in your building.